Technological factors influencing the choice between private wireless networks and cellular connectivity focus on control, security, reliability, and the physical environment. There is no single solution that fits every use case. The decision depends on the specific requirements of the application, such as industrial automation or remote monitoring. Several key technological factors influence this choice. First is network control and management. Private networks give organizations direct oversight of their communications infrastructure. This means they have full control over maintenance, upgrades, and repair schedules. This level of control is critical for essential services, especially during emergencies when public cellular networks may become congested. Private 5G networks can also operate using dedicated spectrum. The amount of spectrum available directly affects speed and the number of devices supported. Dedicated spectrum licenses allow facilities, such as factories, to optimize performance and efficiency. Second is performance reliability and quality of service. Older 4G networks often experienced variable latency. This could range from 30 to 70 milliseconds. 5G standalone technology introduces ultra-reliable low-latency communication. This can reduce latency to 1 millisecond or less. Private networks provide predictable performance because they use dedicated radio and core network resources. Critical control signals are not affected by fluctuations in non-critical traffic. Public 5G networks introduce network slicing. This allows multiple virtual networks to run on the same physical infrastructure. Each slice can be optimized for a specific task. For example, low-latency control signals for robotics or high-bandwidth video for surveillance. Third is the physical environment and coverage. Many private radio networks rely on direct line of sight between transmitter and receiver. Buildings, terrain, and vegetation can reduce signal reliability. In some cases, tall antenna structures are required. Cellular networks reduce this problem by using multiple interconnected cells. Data is passed between towers. This makes cellular connectivity more practical for large or geographically distributed systems. Fourth is security and data isolation. Private networks are often chosen for confidentiality. Data remains within a closed system, and access policies are tightly controlled. This reduces exposure to external threats. Public cellular networks involve third-party carriers. This can raise concerns about data privacy and interception. However, 5G network slicing can reduce these risks by creating isolated and secure segments within the public network. Fifth is economic and life cycle considerations. Private networks usually follow a capital expenditure model. This involves higher upfront costs for equipment and deployment but minimal recurring fees. Cellular connectivity typically follows an operational expenditure model. Initial costs are lower but ongoing subscription fees apply. Industrial systems, such as SCADA, often remain in service for 15 years or more. Cellular technologies evolve much faster. This can create challenges if communication standards change before the industrial equipment reaches end of life. Analogy: choosing between these options is like choosing between owning a private car and using a premium ride-sharing service. A private network is like owning your own car. You control maintenance, availability, and privacy. However, you must pay for the vehicle and infrastructure upfront. Cellular connectivity is like ride-sharing. It is easy to access and works almost anywhere coverage exists. You do not need to build the infrastructure. However, you pay continuously and must share resources with others.